Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome back in a new lecture series that is related to PRC2 course. And this topic, inshallah, I will cover you the direct design method. That is one of the most important method for designing and analysis of two-way slab system. Before the start of this lecture series, I will cover the two-way analysis system by moment coefficient methods, and that lecture series also consists of 6 to 5 lectures. And in that lectures you will see that I will cover a slab system with 4 panels by various by using different coefficients. Okay, that is the coefficient method. Now, a direct design method is another method for analysis of two-way slab system. Basically, this method is developed for analysis of flat slab system or flat slab system. Okay, those slabs which have no beams, basically. So this method is basically used for those slab systems which are beamless, but as well, this method can also be used for slab system that have beams. So let us start this lecture, and we will see that what kind of materials and what kind of examples I will cover in this lecture. Okay, so this lecture is basically an introduction of this topic. Okay, basically I will cover the theory portion of this method, and in the coming lectures, inshallah, I will cover the examples. So, first of all, I have this lecture 5, that is analysis and design of two-way slab systems without beams, flat plates and flat. And these lectures, you can download these lecture series from your Google by Professor Dr. Ali, that was a very famous professor of PVT. Okay, so is basically these slides will a little bit slides will also be followed from Kesari sir. Okay, after that I will also cover the two-way slab system from McCormick book as well. I will use this theory as well. Then I have ACI code 2005, and from that code you will see that different references will be taken and different tables will be selected, but how we can use the course for using two-way slab system. Okay, by DDM. Okay, that is direct design method. I have also 2011 code ACI 318, and from that code I will also show you the different modifications and different changes which will make from 2005 to 2011. Then I have a handbook, okay, of ACI manual that is also related to ACI manual. I will also give you some kind of instructions that how you can use that method from this kind of okay. Then I have Winter Nelson book, okay. I will also cover. I will also give reference of this book as well. Similarly, I have McGregor book as well. I will use also that McGregor book, and I will, inshallah, I try my best to cover some part of examples, okay, from this book as well. So these are the materials, these are the sources from where I will explain this method, okay. So let's start. Basically, first of all, I will start from these slides. Okay, so basically they are the topics. Okay, you will know about a DDM. Okay, and different examples I will cover, as well I have some kind of examples which I have solved, okay, by my own. Okay, and we will see that how we can cover these examples. Okay, so inshallah we will cover these examples as well. So let us start. Okay, the theoretical portion of this method, and then inshallah in coming lectures I will design and analyze different frame sections. Okay, so a DDM is basically it is a new way of analysis. Although before starting this method, I have covered the coefficient method. Okay, the coefficient method is basically included in the ACI code in 1963 code basically, but in the present ACI code, that is 2005-2011, that moment coefficient method was not included in the code, but they are included in 1963. But the provision, or you can use that method as well, because the coefficients are present still in 2005 and 2011, 2015 code as well. So basically, the coefficient method is basically used in that case where the load is distributed to the beams. This means that in the slabs have beams. Okay, while the DDM method is a new method, you can say this is a method which is used for analysis and design of flat system. Okay, which is beamless. Although this method can also be used for those slabs which have beams, but this is most effective method which is used for basically which is beamless slabs. Okay, direct design method is one of the methods for flexible analysis of two-way slab with or without beams. So that is a key point, with or without beams. You can use this method, but it is most effective for a two-way slab system without beams basically. Okay, DDM is a relatively difficult for slabs with beams or walls, that will be used only for slabs without beams. So that is the key thing which I want to mention to you people, that a DDM method is most fruitful method, you can say, in that case when you have no beams. Clear? Next, what are the basic procedures which we will follow? Let us know about what are the flat slabs and what are the slab system. Okay, so coming towards two-way slabs is direct design method in McCormick. So this chapter is basically chapter 16 of the McCormick. Here you can see that what is a flats, what are the flat flats. Okay, so the basic difference, this is a one-way slab system. Okay, because you can see the load is distributed in one direction. There is beam, there is beam. But this is a flat, okay, because you can see there is no beam. So a flat system is such kind of slab system which have no internal beams, which have no column capitals, which have no drop panels. Now, what are drop panels? You can see this, that the ends of the column is tapered. You can see that are a little bit spread at the region of slab. So this is basically, we can say that these are the drop panels and drop panels. Okay, and this is a column capital. You can see the column, the sectional area is increased near the slab system, but there is a rectangular portion over the column. Okay, over the column capital. So the below portion is basically column capital, while the upper portion, that is a rectangular portion, that is drop panel. Now, this is a two-way slab system with beams. Okay, in the previous lectures I will cover this portion, this kind of analysis, that how we can do design and analyze such kind of slab system when it has beams all over its panels. This is a practical example. You can see that this is a column, the slab is supported over the column, but there is no internal beam. So this is a flat system. Okay, so basically you can see this building in this picture. You can see there is no internal beams. So this is a flat system. Okay, so basically this is a kind of difference between flat slab system, flat system, and beams. When you have beams out of the panels. So that is important. Okay. Design of two-way slab system by the ACI code. Basically, in ACI code, the new version, you can see these two methods are basically involved, are presented. That is the direct design method and equivalent plan. Okay. So still we are sticking to this method. Okay, and we are not dealing with this method. Okay. So basically, going forward and start the mechanism of the DDM method, and how we can solve basically DDM method. Okay. So this is the Nelson book. You can also see the definition, the basic definition of the DDM method, and this is the McGregor book. Basically, you can understand that what is the mechanism of the DDM method. Okay, so let us start. Before starting the DDM method, okay, in DDM method, basically the whole slab is divided into north-west direction and north-south direction. Sorry, east-west direction and north-south direction. So the slab is basically divided into two directions. Okay, this is the east-west direction and that is the north-south direction. Before dividing the slab system into north-south or east-west direction, you have to divide the slab system into two different parts, or you can say in two frames. The one is exterior frame and the one is interior frame. In each, because if I assume that this is the east-west direction, if it is our east-west direction, for example, if this is my east-west direction, so you can see this, the whole slab system is divided into two frames. The one is exterior frame and the other is interior frame. You can see there are two interior frames and two exterior frames. The same is for the north-south direction. When we are dealing with north-south direction, we will divide this frame into exterior frame, interior frame, interior frame, and then again this is exterior frame. Okay, this is exterior frame, this is interior frame, this is interior frame. So two interior frame and two exterior frame as well in the north-south direction. So that is the basic mechanism, that whenever we are designing a slab system by DDM method, we have to divide the slab system into east-west direction. So basically we will analyze that frame system in east-west direction, and then we analyze that slab system in north-south direction. In other words, if the slab system is a rectangular shape, so first of all we analyze in the longitudinal direction, and then we will analyze the slab system in short direction. The short direction is basically north-south direction, and the longer side is basically east-west. But if it is a square shape, so then you can see that east to west direction and north-south direction analysis will be same, design as well as. Okay, so you must know about exterior frame and you must know about interior frame. In exterior frame, you can see that the columns, basically the slab is discontinued at one edge, and the columns comes at the edges of the slab. Okay, while in interior frame, you can see that the columns comes into the middle portion of the frame. This is basically a separate frame, and this is basically a separate frame. Okay, so here we can also see that this is exterior frame because the slab is discontinued. Okay, so moving forward, I think you must understand what is exterior frame and what is interior frame. For complete analysis of slab system, frames are analyzed in east, west, and north south direction. Yeah. So you must know about the frame will be divided. You can see this is exterior frame in north, in east west direction, and you will see that this is the north south direction, but this is the exterior frame. So the slab is analyzed in both directions. Clear? Because it's a two-way slab system and you have to provide reinforcement in both directions. There are some limitations. Okay. Whenever you are using the median method, you must know that there will be some kind of limitations. The first limitation is this: the median is useful for analysis of slabs, especially without beams. The method is applicable when some limitation is discussed next. Okay. The first limitation is that the slab system, there should be 3 continuous spans. 1, 2, 3. This is the basic assumption. This is the basic limitation. Okay, that you have minimum 3 spans, and the spans should be loaded by uniformly uniformly distributed load, and you must ensure that your live load to dead load ratio should be equals to or less than. L means live load and D means dead load. The live to dead load ratio must be less than or equal to 2. Okay, and the third limitation is that if you have interior span but its length is changed from the exterior panel length, that is L1 and L1. L1 and L1 are the exterior panel lengths. If the interior panel length is greater than 2L1 by 3rd, it should not be more than greater than, it should not be more greater than 2L1 by 3. Okay. So the other limitation is that a column offset. Now you can see this center line of these columns, but the important thing is that you can see this column is offset from the center line of these columns. Now, how much offset is acceptable? The code says that a column offset should not be more than 10%. Means 10% upward, that is L2. Then L2 is this direction, this span. Okay. In short, in perpendicular direction, basically the distance in perpendicular direction, you can see this one. Rectangular slab panels 2 or less. It should be remember this L2 divided by 10. Okay, the ratio must be less than or equals to this offset. Okay, so if we take this as 1 feet, okay, if we let's say, for example, this column is displaced to here, okay, by an amount of, let's say, this amount is 2 feet. Okay, now we can see that this is 20 feet. This is L2. So in 20 divided by 10, you can get 0, and this is 2. So the offset is basically we have 2 feet. Now this is equals to 2. Okay, so this offset is acceptable. This way of pattern is acceptable. But if this offset is increased, let's say this is 2.5 feet offset. The column is this, you can say the column is offset by an amount of 2.5 feet from the center line of these columns, then it will not be acceptable. Okay, and we cannot apply the deviation. So this is the limitation. The other limitation is that the panel should be rectangular. Okay, although it can be square, deviation is also applied to a square panel, but if it is in a rectangular shape, The panel is in rectangular shape. So the longer to shorter span ratio should be less than or equals to 2. It should be remembered. It's the basic condition of the all know, okay, that the shorter direction should be half of the longer direction. Or you can say the longer direction should not be more than 2 times of the shorter direction. So these are some kind of limitations. You can see these limitations in these books as well. Okay, here you can see in the Greco book, you can see here at page number 653. Okay, and there must be a minimum 3 continuous span. The rectangular panel must have a longer to shorter ratio that is not greater than 2. Successive span lengths in each direction shall not differ by more than 1/3 of the longer span. That is the same this 2/3. Okay. The other limitation is that column may be offset. Okay, I will explain this one. All load must be due to gravity only and uniformly distributed. Gravity uniformly. The service unfactored live load. Now, live to dead load ratio. The serve, but that is an unfactored load. So not be exceeded to. For a panel with beams between supports on all sides, I will explain this in later stages. Basically, needs some kind of explanation. Okay. So this limitation is basically stands where we have to provide beams over the panel edges. Okay. So you can see this basic picture. Okay, and this picture is basically portrayed in the north-south direction. Okay. So you can see these columns, and you can see this is the interior frame and this is the exterior frame. Okay. Now, the one basic assumption, or you can say that is the basic mechanism of the DDM method, that each interior or exterior frame is divided into 2 strips, and that strips is basically, the one is column strip and the other is middle strip. So you must know about that, these strips. Okay, you can see in this picture that this is the exterior frame and this is the interior frame as a whole in north-south direction. But you can see the exterior frame is divided into 2 distinct parts. The one you can see this is that the exterior frame is divided at the middle, and the interior frame is divided at the middle on both sides of the column. So that panel is basically, you can see, this is a very good picture and very good illustrations you can see in this picture. You can see that this is the exterior frame. Okay, and the exterior frame is basically divided into 2 parts by this line. Okay, now the strip which is near to the column is called column strip, and the remaining strip is basically called the middle strip. Okay, so similarly, you can see this picture. This is the interior frame in north-south direction, and you can see from both sides of the column, the frame is distributed into 2 parts. Now, one is this part, you can see, divided by this line, and the other one is this line. Okay, so basically you can see this area. This area is basically the whole strip is basically known as column strip. You can say this strip is column strip. Now, the rest of the strip, the rest of the area, that is that one area and that one area. Okay, so combinedly this is known as middle strip area. Middle strip. Okay. Now, the below picture you can see this is east-west direction, and in the same way the exterior, this is the exterior frame, and they are divided into column strip, okay, and header strip. And similarly, you can see this interior frame, and that is divided into column strip. This is basically column strip width, okay. This is the column strip width, okay, and you can see the half of the middle strip, and this is the half of the middle strip, okay. So the total width, one of the most important things you must know about L1 and L2, okay. What is L1 and what is L2? If it comes to the north-south direction, you can see that L2 is the basically the length, the width of the both column strip and middle strip in interior frame or exterior frame. Okay, so we have this is exterior frame, and the total width of the column, combined width of the column and middle strip is basically known as L2. While the same thing is stand for the interior frame, the combined length, you can see here, it includes, this is L2, clear? This is basically L2, okay? So you must know about L2. Now, what is L1? L1 is basically the longitudinal distance from one center of the column to the other side. This is basically L1, okay? Similarly, here you can see from the center line of the column to the center line of the adjacent column, this is L1. But the orthogonal distance, you can see the width of the frame is basically known as to be L2. So you must know about L1 and L2. Whereas Ln is basically the flare distance. Okay, the flare distance amongst, or you can say between the columns. Okay, so that is the flare distance. Flare. So you must know about L1, L2, and Ln. Okay, so here you can see in this picture, okay, you can see this is the interior frame, okay, and you can see the L1 and L2, okay, and this is the basic mechanism which is explained by the author in a different way. Okay, you can explain this in various ways. Okay, so basically each frame, that is interior frame and exterior frame, they are selected separately and they are analyzed separately. Okay, so you can see here the interior frame is selected and they are divided into, basically you can see this line is basically the center line of this panel, of these 2, 3, 4 panels. This is the center line, and this one is also the center line. So the mechanism is that you will draw a central line of the panels on both sides of the columns, okay, both sides of the columns, and it will give you the interior frame. Now the column center line is this one, okay, and half to the center line and half to the center line of the panel. From the center line of the column, you can see half width of the panel on one side and half width of the panel on the other side. Clear? According to ACI, where the transverse span a panel on either side of the center line of suppose there is L2 shall be taken as the average of adjacent transverse spans. Okay, so this is the L2, okay? And this means that shall be taken as the average of adjacent. Okay. ACI code 8.10.3.2.2, where the transverse span of panels on either side of the center line of suppose varies. Okay, L2 shall be taken as the average of adjacent transverse. This means that this, whereas you can see this is 20 20 feet and this is also 20 feet. It varies. Let's say this is 10 feet. So you have to take L2 is the average, okay, of that. This means that 5 plus 20, 25 divided by 2, you can say that will be your L2. And L1 is the basically, for example, this panel length is changed from this one. So you have to take the average. Let's say this is 25 feet and yes, this is 25 feet and let's say this is 24 feet. So you have to add 25 plus 24 divided by 2, that will be the average area. So then you have to select, okay, the average. Okay. In this case, basically you can see this is 25 feet, this is 25 feet. So this means L1 is constant in this panel, in this panel, in this panel, in this panel as well. Similarly, in that direction, in shorter direction, L2 is constant. The next, that is the east-west direction exterior frame. So you can see here, the exterior frame, what is L2, where is L1, and the very important note is that you have to, let's say L2 is the distance to the outer edge from the center line of the panel to the outer edge of the slab. And you see this dotted line is basically the center line of the columns. So L2 is not a distance from the center line to the of the panels to the center line of the column, but it is actually a distance from the center line of the panel to the center line to the edge of the slab. So you have to add half width from the center line to the panel center line plus h2 by 2 means this is the half of the column. So you have to add half of the column with that half distance, then you can get L2. So this thing should be clear. L2 is the panel width. This is the formula for exterior frame. Okay, this is only for exterior frame, not for interior frame. L2 you can see panel width divided by 2 plus h2 by 2. So this is a very important thing. Now you can see, as I already mentioned you, that you have to distribute the interior frame in 2 steps. This dark portion is basically it shows us the column steps. But from the center line of the column, okay, this is the column center line. So half column step and half column step. C is by 2 and C is by 2. This means half column step from the center line of the columns. And this white portion on both sides of the center line of the column, this one and this one. This is the middle strip part. Okay, middle strip part. So L2 is basically in this case is the total distance from this line to this line. This means from the center line of this panel to the center line of this panel. Clear? And what is L in? That is the clear distance from the face of the column to the other face of the column, and L1 are the central line distance. Now, very important note: whenever you are dealing with a DDM method, you have to determine column step width. Now, column step width C is by 2 equals to least step is 1 by 4 or L2 by 4. So the least value, the smaller value, which gives you L1 or L2 by 4, you have to select. That is your column step width. A very important note, you must keep this in mind. Marking column step for interior frame and marking middle strip for interior frame. Okay, so you can see here, this is the way that how you can determine the column step width and the column step width and the middle strip width. So you can see here we have 20 feet in this direction, that is the center line, center to center distance in between 2 columns, and this is 25 feet. Okay, so in north, this is you can do this analysis in east-west direction. So you can see here, what is your L1? L1 is your center to center distance, that is 25 feet, and increase also a center to center distance, that is 20 feet. So your column strip and middle strip widths are given as follows. Your column strip width divided by 2, half of your column strip width, least of L1 by 4 or L2 by 4. So the least value of L2 is 10 here because L1 is 25 feet. So 20 divided by 4 will be 5 feet. You have to ignore L1 because L1 is more than L2. You have to choose your least value. Okay. Now this is the exterior frame, and in exterior frame you can see this is your how you can determine your column strip. And here you can see that this is not divided by 2 because the shaded area it will give you the column strip. Now the width of the column strip, you will use the same formula. Column strip is equal to minimum panel width divided by 4 plus 1/2 of the column size. Now you have to keep this thing in mind, minimum panel width. Minimum panel width. This means L2, sorry, your this direction and this direction. Okay. You must take care about this calculation whenever you people are calculating your column strip width. So you can see this is your panel. Yeah. This is your panel. Okay. So you have to take the dimension which is the most smaller. In the present case you can see this is 20 and this is 25. So basically it says here that you have to take minimum panel width. So minimum panel width is 20 divided by 4 plus half of the column size, and this means this is your column and you have to add this half distance. Okay, that is the half of the column width. So here you can see it will give you column strip width L2 equals to, now L2 is the whole distance, okay, which includes both column strip. You can see this is the column strip width, okay, and this is the middle strip width. Clear? This is middle strip and this is column strip. Now you can see L2 is equal to 1/2 of 20. Now that basically select the minimum value or the minimum panel width. Okay, so 20 divided by 2 plus half of the column size, and this is 14 by 14 column, divided by 12 to convert it into feet because that is 14 feet inches, and they will take the half. You can see this formula, half column size, and column size is 14 inches. To convert it into feet dividing by 12, you can get 10.58. Now what will be the middle strip width? So for middle strip width, you can see this formula. Middle strip width will be equal to L2 minus column strip. So L2 is basically how much? You can see 10.58 feet. So subtracting the column strip width from this 10.58 feet, you will get the middle strip width. So as you can see, your column strip width will be what? Okay, minimum panel width divided by 4 plus half of the column size. This gives you your column strip width, and then you will get your middle strip width, that is your N2 minus 5.5. So you have to remember this calculation because we will do example on this kind of calculation. Okay, so you must keep this thing in mind, that how we can determine the column strip width for exterior panel, for exterior frame, and how we can determine the column strip width and middle strip width for interior frames. So the same analysis will be used in the north-south direction as well. The other important thing is that you have to calculate your static moments. Now, what is static moments? So static moment is that you can see this panel, okay, this is the interior frame, okay, and that is the span of your frame, okay, Ln, showing the span of the panel, of the interior frame, okay, and this is show L2 is basically show the width. So M naught is basically the static moment, and this moment is basically W L2 and divided by Ln squared divided by R. This means this is basically how that if looking to a slab system in elevation, okay, you can see this is your slab, okay, in between two columns. Now you can see the movement is negative at the faces of columns, going to the positive direction and then again going to the negative direction. So basically this is your positive movement, this is your negative movement. Okay. So M naught is basically the sum of both moments. Okay. This is basically your M naught. This is basically your M, and that M naught is basically equals to WU, that is the loading over this panel, multiplied by the span of this panel, that is Ln, slab span, multiplied by the width of this slab. Okay, what will be the width of this panel? And you can know that as it is in both direction, okay, because that is the summation of your column strip as well as of your middle strip. So L2 is basically from the center line of your adjacent panel to the center line of your adjacent panel, and that is L2. So M naught is basically what WU Ln multiplied by L2 divided by 8. So L2 is the width and Ln is the span. So therefore W Ln squared into L2 divided by. So that M naught, that is your total movement. Now that total movement is basically divided into your negative movement and into your positive movement. This means that if I draw again this picture, okay, so for example, this is the distribution of moment, okay, this is the distribution of the moments, okay, so how much this negative moment and how much this positive moment. Now you can see that how we can get this positive moment and how we can get this negative moment. Clap. So here you can see the positive moment is basically 0.35 M naught, and the negative moment is 0.65. So this positive moment is basically 0.35 M naught, and this negative moment is basically 0.65 M naught. So this is the distribution, but this distribution is in longitudinal direction. We have to distribute this moment in other direction as well, okay, because we have to distribute this moment, because this is a two-way slab system, and in two-way slab system the moment flow is basically in two direction. So once we got this moment, okay, we have to distribute this moment in that direction as well as in this direction. Similarly, that negative moment in that direction, okay, and in that direction. Like now we can see that this area is basically divided. Okay, this area is basically divided into, this is your column strip as well as this is also your column strip, and this is basically your middle strip, and that is basically your monster. Okay. Now what we have to do, we have to distribute this 0.35 in your column strip as well as in your middle strip. Clear? So for that we have to choose coefficients, and code gives us these coefficients. Clear? I think so this 0.65 is basically equal to 1/12, and this 0.35 I think so this is equal to 0.4. Okay, that is if you see the, for example, if you investigate the moments of the fixed beam, okay, that is supported, okay, on both sides by your fixed beams. So in that case, you can see your moment is basically, I think so that is WL square divided by 2012, and that is basically WL square divided by 24. I think so. So, for example, if I check it, one divided by 12, here we got 0.083. 1 divided by, for example, 1 divided by 24 is 0.04. So, for example, if you search these in the format book, I think so this explanation is present here, and they select that moment as well. That is, if you have a knot, okay, so that moment is basically distributed. This is your M naught, and this is the case for, you can see that is 1 over 12 and that is 1 over 24. So this moment is basically 0.35 and this moment is basically 0.65. Okay. So that is your M naught, that is your whole moment, and that is your negative moment and positive moment. And then you have to distribute that moment in your transverse direction. And for transverse direction, we have to choose these coefficients. So basically, how we can distribute that moments. So you can see here that the positive moment is distributed transversely by 0.65 and negative moment by 0.75. This means that 0.60 time moment of the positive will be remain in the column strip, while the rest of the moment will go towards your top of the middle strip, okay, in both directions. And similarly, if the face of the column, that is the negative moment, 75% moment will remain in the face of the column. This means in column strip, while the rest of the moment will be towards your middle strip in both directions. Clear? So that is the whole distribution of your moment. But remember, this is basically for the interior panel in interior frame system. Okay, in interior frame system we have exterior panel. This must be remembered. You have to see what is your, in each frame, that is exterior frame or interior frame. Let's say this, you can see this is your interior frame. So in interior frame, this panel, and this panel, these are interior frames. And this panel and this panel is your exterior panels. So in exterior panels, the moment distribution is different, while in interior panels, the moment distribution is different. So you must take care about it, that you can see M naught is the same formula, sometimes L in the span length of the exterior panel is different from your interior panel. Okay, so you must keep this thing in mind, that you have to count for these moments, for these variations. Okay, so the M naught formula remain constant. Okay, and the coefficients is different. Okay, you can see M positive exterior, M negative exterior, M negative interior. So how you can distribute these moments in this case? You can see the positive moment is almost equal to 0.52, while in the interior panel that is 0.35. And here you can see an exterior at the face of the exterior column. Okay, at the face of the exterior column, M exterior negative is 0.25, that is 26% of your M0. While the interior movement, that is the face of the interior column, 0.70%, means 70%. So you have to keep this thing in mind. You can see this is also your column and this is also your column. So the moment distribution in this case is a little bit different from the other panels. Okay. This is your exterior column. Okay. So in exterior column the moment is less. Okay. While at interior column, you can see this is your interior column. Here the moment is 70% of a notch. Okay, while here you can see that is 29%, almost half. Okay, not. While this moment is 0.52% of not. Okay, and then again you have to distribute this moment in transverse direction. Okay, and for that you have different coefficients. So this is the variation. Okay, that you have exterior panel, you have interior panel. In each interior frame as well as in exterior frame. Okay, you can see the coefficients for transverse distribution of those longitudinal moments. You can see 60% of the exterior of the positive movement will remain in column strip, while the rest 40%, half to this middle strip and half to this middle strip will flow to those strips. While this one is very tricky. Okay, that it says that 100% of the movement of the 29% movement of a knot will be lying in column strips and no distribution, no flow of the movement towards the middle strip. Means the movement in middle strip will be slow. While here you can see 75% will remain at the face of the column, while the rest, that is around about 25%, will be towards this direction and this direction. Okay. So these are the complete coefficient you can see. 100%, 60%, 75%. This is the transverse distribution of them. Okay. So in next lecture, inshallah, this is all about a theoretical portion. Okay, you can see the whole theory in these books. Okay, and how we can fix, basically how we can illustrate these theories. Okay, so in Cormac book as well as Winter Nelson book. This is Winter Nelson book. This is 15th edition, page number 397. You can see the whole theory and the whole limitation. This is my McGregor book. Okay, you can see all these data, all these details, political details, all those books. Okay, and next lecture, inshallah, I will explain this example. Okay, that how we can apply the DDM method to actual frame system. Okay, so I will explain whole steps. Okay, in a very detailed way, and I will analyze and design this panel system. Okay, so if you have any question, any comments, please share your comments with me. Watch the video and enjoy. Thanks.